means, for example, a rectangle with a triangle sitting on top of it and maybe a trapezium stuck underneath. Basically, shapes made from other basic shapes stuck together. Look at the foundation videos. I'm not going to do those. I will do some of the questions that have not been seen in the foundation section because they don't have them in the book. But so these couple I will do only. This is question 3 on page 32. It's a compound shape, and as far as I can see, a square there, and I can see all quarters of circles. Anyway, Alex is making badges out of cards, so that's her badge. She takes a square of side 6 centimeters. Time to label it. So the full length of that from here to here, and it's a square, is 6 centimeters, which means it's also 6 centimeters from there to there. Alright, goes without saying, goes without labeling, it's a square, so that's important. And she cuts quarter circles, so that's a quarter circle, and that, and that. Now the radius is 1.5. Let's put the radius over here. That's 1.5 centimeter radius. Label it where it counts. So that part across there is 1.5. That's a 1.5. All these little white bits here at the edge are 1.5s. Calculate the area of the badge and give your answer to 1 dp. Alright, it's important. Okay, area of the badge. Essentially, I've got a square, and then I've got to take away 4 quarters. Now, 4 quarters basically is an entire circle. So, in other words, area of the square, subtract pi r squared, where the radius is 1.5. I'm doing it in one step because this is higher level. So here I go. Area of the badge. So I'm not going to say area equals pi r squared. I'm just going to say area equals 6 times 6. That's the square taken care of. And then you chop off a whole circle, which is pi times radius squared. Now, just to show a bit of working, that's going to be 36 take away. I'm now going to work out pi times 1.5 squared. 1.5 squared times 3.14. That gives me 7.0. Stop being glitchy. 65. I'll probably round this anyway. Take away from 36 is 1 dp. Well, that's going to be 28.9, and that's centimeters squared. There'll be marked for the unit perhaps if it's given, and that is 1 dp. Is that alright? Did it in one step? Just review that. 6 is a 36. Pi times radius squared. The radius of each of these quarter circles is 1.5 centimeters. It says in the question. So pi r squared comes to 7.065. Do a subtraction. 28.9 to 1 dp. I didn't bother writing out the rest of the decimal places because they're not significant in the question. And that was that one done. Next one's rather pleasant. Here we go. It says Sammy's making badges, so this section's all about badges. He's making badges to the design shown. Okay, very good. Sam uses silver foil for the surround of the white center shape. For the surround of the white center shape. So that's the white center shape. The surround is this part. She's going to put, or he's going to put, lots and lots of silver foil across here. Now it's a he. Okay, so Samuel has 45 centimeters square of silver foil left. Here's the question. Does he have enough foil to complete the badge by putting silver all around this little blue area here? Show you working. Essentially, you've got to work out the area of this part. Okay? If you can work out the area of the blue bit, then we've actually worked out the area of the surround around the white part, and therefore to see if it comes to under 45 centimeters. So that's what we're aiming for. So let's just look at this little shape then, see if we can do it in an easy way. Alright, I've got if that's one across there, then so is that. I have to assume that. I've got no other reason to think otherwise. So if I complete this little square by drawing these yellow bits, and if it's one up there, it's going to be one up there as well, one across there. So essentially I've got 2.5 across plus an extra 1 plus an extra 1. So essentially from, let's just make it clearer, from here to here I've got a length of 2.5 plus 1 plus 1, 4.5. Okay, and also from here to here, wonderfully drawn again, is 4.5. Try and make that fit somehow. Centimeters. Alright, beautiful, stunning, lovely. So easy to control this pen when it's really behaving itself. Right, so there I go. Essentially, if I can work out the area of my new square and subtract it from my big square, I'm going to find the area of foil that I'm going to need. Now, I don't need this white stuff, so essentially I'm going to work out the 4.5 by 4.5 and take away the area of these little yellow parts here. Let me just shade them out. This is not required. Don't want it at all. Don't want that. I'm going to cut it out. So that's that. Let's just cover over my 1 so you can't see it now, and get rid of that one as well. So here I go. Let's just start doing the calculation in blue over here. I've got 4.5 times 4.5 equals whatever my calculator says. So 4.5 squared, doink, 20.25, and that's centimetres squares. Now I've got to take away a 1 by 1 here, which is 1, that's 1, and that's 1, and that's 1, because it's 1 by 1 centimetre square. So I'm now going to go 20.25 centimetres squares, take away 4 centimetre squares. That's my 4 lots of 1, and that will give me something else. 16.25 centimetre squares. Now that is the area of the white bit. Now let's just work out the area of the entire 7 by 7.5 by 7.5 square. That will include the white bit, and there's little yellow bits as well. Here's my next step. So 7.5 times 7.5. Oh, this is terrible. Make it look like a 5 now. I tell you, when this stuff works well, it's brilliant. When it doesn't, I just want to punch the machine. Right, so 7.5 times, I think that's called computer age, isn't it? 7.5 times 7.5 is 56.25 centimetre squares. So if I take away this little white bit from that entire blue bit, I should get the area of just the blue bit itself. That doesn't include the white and yellow bits. So here I go. So foil needed, or rather area of foil needed, is going to be 56.25, the entire area bound by the 7.5 by 7.5 enclosure, 0.25. Take away this part here, 16.25. Now, are we going to make it? Let's just take a look. Oh, I can see it's exactly 40. Yes, I love it. That's 40 centimetres square. Therefore, does she have enough foil? Therefore, Sam has enough foil, because I've proved it. Oh, please. To complete the badge. So lucky for him, he's got 5 centimetre squares left over. He can do something nice with that, I'm sure. I'm going to stop. They're the only 2 questions I want to do. I'm not dealing with the basic formulas, 2 pi r, pi r squared, pi d, and what have you. I'm not dealing with half base times height and all the rest of it. I'm leaving that to you to review using the foundation videos that I've already done for you. So click on the link and go back to the foundations, get some of that if you need it, but certainly look at these 2 questions because they're like the top end of grade C in this particular topic. Thanks for watching.